Okay, radical functions, we're starting. Let's talk about some properties. So when I explain things today, you have an idea of what I mean. Okay, when you first see this symbol, a lot of you think that's square root, okay? Which is correct in a sense, but this is actually called a radical, okay? We say square root because the most commonly used radical is a radical with a 2 right here. Okay? So when you see a radical without an index, it's a square root. But this is really called a radical. The number that is in here is called the index. Okay? And when we go through this chapter with radical functions, we're going to see more than just a square root as an index. We're going to see 3 for cubed root, a 4 for fourth root, a 5 for fifth root. We can do 6 for sixth root, and so on. So until now, the only one that you're used to is like square root, and I would say square root of 36, okay? Because when there is no index there, we assume it's 2. The number underneath the radical is called the radicand, okay? And that's just some terminology. The big thing you need to know is that this is a radical and this is the index, right? That would be the big 2 words that you need to know, radical and index, okay? So we're going to go over a couple of things here before we move on. When I'm doing the square root of 36, okay, if I was maybe a 4th grader and you're going to tell me what is the square root of 36? 6, right. But as a 4th grader, I would ask why. Why is the square root of 36 6? And we would say, yep, because 36 is 6 times 6, and 2 6s, I take 1 out. Why 2? Because there's really a 2 here. That's why we call it a square root. Okay? So when I have a square root, I need 2 of something to take 1 out. When I have a cubed root, what do you think is going to have to happen? I need 3 of something to take 1 out. Very good. And I can break down an 8, 4 and 2, and 4 is 2 and 2, and there's 3 2's I can take 1 out. So a cube root of 8 would be 2. Okay. Now something with radicals, every time you study a function, they kind of come with their own set of rules. When we're studying radicals, we are not going to recognize complex numbers. So what does that mean? That means if I have a negative underneath the square root, that's no solution. There are no imaginary numbers anymore. Before, when we square rooted a negative number, we took out an I. Remember that? Okay, we're not going to do that anymore. If I were to have a square root, let's say the square root of a negative 4, before I would say 2I. Now it's just no solution. There are no complex numbers anymore. Okay? The other thing that's gone is the plus or minus. If I square root something, it's no longer plus or minus 6, it's just 6. Right? The answer you get in your calculator. If you do square root of 36 on your calculator, it gives you 6. Okay? So the big thing here is when you square root negatives, it's no solution. And that rule actually follows into any radical with an even index. Okay? So if I have a 4th root of a negative number, that's no solution. If I were to have an 8th root of a negative number, that's no solution, right? You cannot have an even index and a negative number. That's no solution. However, odd index, a 3, a 5, a 7, you can do any number. And the reason is because if I have an odd degree, let's say cube root, of a negative number, you can do 3 negative 2's and get a negative 8. So you can cube root a negative number and you get a negative answer. Okay? And that stems all the way back to probably in middle school when you guys learned that any number, let's say negative 3, to even power is going to be positive. If you have a negative number to an odd power, that's going to be negative. You guys remember that rule? A negative number to an even power is always always positive. So negative 5 to the 12th. Since 12 is even, it's going to be a positive answer. Okay? Negatives to odd is always negative. Okay, so that's important to recall that in a little bit here. Okay. All right, so let's also do some of these and learn how to use our calculator. So if you look at the first example here, a square root, we're doing real square roots. So again, you can't do negatives and we're not going to do plus or minus. Okay, so what is the square root of 225? 15, and you can do that in your calculator if you want, okay? Not plus or minus, just 15. What's the square root of 0.0049? 0.07. Okay, 0.07, very good, and you can put that in on your calculator, right? Square root. Okay. How about the square root of a negative 121, 1 over 121? Very good, you cannot square root a negative number, no solution. What about the square root of 64 over 169?
Don't get me.
Okay, when you're doing a fraction, you can square root the top and square root the bottom. What's the square root of 64? What's the square root of 169? 13, okay? And if you didn't know that, you can also again use your calculator and go square root 64 divided by 169, push enter, it'll give you a decimal, but how do we convert decimal to fraction? Do you remember? Math, enter, enter. Very good. It'll give you a decimal, and then you go math, enter, enter on your calculator, and it'll convert it to a fraction for you. Okay? Because if you're square rooting a fraction, you should have a fraction as an answer. Okay, let's do some cube roots. What is the cube root of negative 64? Do you guys know how to do a cube root on your graphing calculator? So to do cube roots, you go math, and it's number 4 here, cube root. So you push enter, and then I can put in negative 64. Right? And I get negative 4. Okay? So try 0.0049. What's that one? Math, cube root.
Wait, where are you getting that one? Oh, that's the top. That's the square root.
Oh, where am I in the wrong spot? Oh, I'm sorry. Negative 4. What about 0.125? 0.5, very good. Okay, there's that cube root button you can use. How about, which one's next here? 27 over 216. And you can cube root each one. You can cube root the 27, cube root the 216. Or you can put it in one big fraction in your calculator and go math, enter, enter. What do you get? Negative 1/2. Good. Yep. Because cube root of 27 is 3. The cube root of 216 is 6. 3 6 is 1/2. Right? And whenever you cube root a negative, your answer is negative. What about this decimal thing? Cube root of that. 0.07. Very good. You can put that in your calculator and get 0.07. Okay. Now let's try 4th roots, and I'll show you how to put that in your calculator. Anything more than 3. Anything more than a cube root, you have to use a different button. And you have to put the index you want to do first. So if I want to do 4th root, 5th root, 6th root, whatever, anything more than 3, I put the number in first. So since I want to do 4th root, I'm going to put in a 4. And then math, and then now it's the 5th one down, this x with the square root. And that's telling my calculator 4th root. The number in front of it will become that x. And then I can put in the number, 16, and I get 2. What's the 4th root of negative 16? No solution. And even if you forget, if you do the 4th root of negative 16, it should tell you error. So even if you forget, it'll say, oh, it's not, that's an imaginary number, you can't do it. Okay? So it will remind you, oh yeah, you can't do negatives with an even index. How about fourth root of 0.0081? What's that? 0.3, very good. How about 10,000 over 81? Thirds. You have to fourth root 81 also. So if you should have this 4 and then the X button and then parentheses 10,000 divided by 81. Close your parenthesis and then math enter. Okay. Good. Okay. Let's do a couple more here and then we'll move on with variables. Okay. Square root of 36 is going to be 6. Very good. Not plus or minus, just 6. The square root of 0.25 is going to be 0.5. Very good. If you had 1/2, that's not wrong. But if you ever square root a decimal answer then is okay. If you're square rooting a fraction, then you need a fraction answer usually. How about cube root of 64? Right, cube root of 64 is 4, but I have this negative out front, so that just stays out front. So it's -4. Okay. What about the cube root of -27? -3, very good. You can have an odd index and a negative number, that's okay. Okay, so when we have variables, right, we have to think what our rules are. Square root means 2 of something, you take 1 out. Cube root is going to mean 3 of something, I take 1 out. Fourth root is going to mean 4 of something, I take 1 out. Okay, simple enough. All right, so let's look at square root. You square root the number, and then we're going to square root the variable. So what's the square root of 16? 4, because 2 4s, I take 1 out, right? Okay, now think about this. If I have x squared, that means 2 x's. What's my rule? 2 of something, I take 1 out. So 2 x's, I take out an x. Okay, what's the cube root of 27? 3, right? Because 27 is 3 3s, I take 1 out. Now you can just use mental math. If I have 6 y's, how many group of 3 is that? 2. And if you don't get it, right, maybe sketch it out the first couple of times so you can see, oh, 6 y's, here's a group of 3, take 1 out. Here's a group of 3, take 1 out. That means I'm taking out 2 y's. Good. How about fourth root? If I have 20 x's, how many groups of 4 is that? 5. Very good. If I have 28 y's, how many groups of 4 is that? 7. Very good. Okay. Okay, now let's pause here for a second. When you get into upper level mathematics, which we are this second semester, a lot of your answers this semester are going to have answers with definitions behind them, with defining your answers, so it's more precise. Okay, so we have to remember, if I have an even index, right, like a 2 or a 4, I cannot have a negative radicand. That means a negative number underneath the radical, right? Okay, so we know if I have a negative number and it's raised to an even power, it's always going to be positive. But if I have a negative number raised to an odd power, it's going to be negative, right? So whenever I have an even index and a variable answer to an odd power, you have to have absolute value signs. What? Right? Okay? This is what I mean. Whenever I have an even index, a 2, a 4, right? And I look at my answers, if I have a variable answer with an odd power, right? See how 5 is odd? 7 is odd. X to the 1 power 1 is odd. I have to have absolute value signs to say no matter what number I sub in for X or Y, it's gonna be positive. So it looks like this. My final answer, I would have absolute values there. and I would have absolute values there. When I have an odd index like 3, we don't have to worry about absolute values because I can have a negative underneath a cube root. It's only if you have an even index, any variable to an odd power has to have absolute values. Okay, let's try another one. Okay. So 5th degree, so what do I need? Groups of 5, right? What's the 5th degree of 32? Or the 5th root, I said that wrong. 5th root of 32. 2, very good. I have 10 y's. How many groups of 5 is that? 2. Since it's odd index, I don't have to worry about absolute value. You're fine. Okay? 5 is odd, so we're okay. Try another one. Okay, square root. If I'm doing the square root of 9b squared, what's the square root of 9? 3. How many groups of 2 go into 2? 1, so this is b to the 1. Now, this is an even index, right? It's square root. And this is an odd power, so I need absolute values. To say no matter what b is, that'll always be positive underneath there. Okay. Here's another square root. So how many groups of 2 go into 8? 4, so it's a to the 4th. How many groups of 2 go into 18? 9, okay? So I have an even index. There's really a 2 there. Do I have a variable of an odd power? Yes, the a is fine. It's this b. So the b to the 9th is the only one that needs absolute values. Only the one with the odd power. Cube root. What's the cube root of negative 125? Negative 5, very good. How many groups of 3 go into 3? 1. It's an odd index, so I don't have to worry about absolute value. Okay. How about this one? What's the square root of 25? How many groups of 2 go into 6? 3. Am I done? No, because this is even and this is odd, I need absolute values. What's the cube root of 343? 7, good. How many groups of 3 go into 9? 3. How many groups of 3 go into 12? 4. It's an odd index, so I don't have to worry about absolute value. Good. One more, right? What's the 4th degree of 16? 2. How many groups of 4 go into 16? 4. How many groups of 4 go into 20? Am I done? Which one needs absolute value? Right, because this is even 4 and this is odd 5. That needs absolute value.